Hey everybody. And Gino. Thanks for coming to listen to me talk about GraphQL. How many people were in the GraphDefinition talk that we just had? A few. Okay. So I worked up GraphDefinition and GraphQL together. I'll come back and mention GraphDefinition at the end. I'll tell you about GraphQL and why I think it's a really useful thing, and encourage you all to have a good look at it. So here's our problem statement. FHIR, as you know, has a well-described modular schema, quite modular, and we define the CRUD operations, read, update, delete, and create. And then you build client applications against an API. Yeah, that's pretty straightforward. So your user interface requires a set of resources. Say you do something really simple and say, I want to see the patient's problem list. I just search on creation, I get a condition, I get a set of condition resources back. I'm going to need to look up a number of resources that the condition resources refer to as I display them to the user. Or in the case on the slide here, a list of encounters. For each encounter, I had to fetch the patient to get the patient's name. I had to fetch the consulting physician and the ward location so I can display information out of those records. And it's pretty similar for almost every operation that you do for a user-facing client. And it's the easiest way to do it, which is the way we do it when we first do it, is we fetch the encounters and we iterate through the encounters that we got back, fetching all the related resources that we want. We can cache up local copies of the fetched resources if we want, but there's a price for doing it that way. One is bandwidth, but actually particularly latency. And as the latency of the network increases, the price of doing this increases. And also you have to manage the cache. If you're going to manage a local cache, you've got to worry about cache currency. Another way to do it, once you get to know FHIR a bit better, is to fetch the encounters and ask the server to send you all of the relevant resources using _include. I'm not going to show you that example, but you can do that. And then you don't have to do any thinking on the client because any of the relevant resources that you need will be in the bundle that you got back. So you just grab them out of the bundle and look it up. So that's okay, but the price of that is the bandwidth goes up because each time the server sends you a list of encounters, it'll send you the relevant referenced resources, even if it sent them to you on the last list of encounters, because it doesn't know anything about your cache management. So bandwidth goes up, but your latency goes down, and you don't have any cache to manage locally. So that's not exactly a wonderful solution either. But the ideal would be if you could just tell the server what it is you actually want to display and to go off and do all that work for you and just send back just what it is that you want to display. So in this case, you tell the server what elements from encounter you're going to display, and you tell it to go and look up the other resources and replace the references with the elements that you want out of those resources that are referenced. There's no work for the client. Your bandwidth goes right down. Your latency, you only hit the network once, so it's nearly ideal for a client. There's one price, which we'll come back to later. But if you're writing a client that's user-facing, that would be pretty cool, right? And that's what GraphQL does. So GraphQL is a language to tell the server what it is that you want. So you send the query against the graph of resources that the server has and get back just the structure that you want returned. So GraphQL, before I go on, it's a language that was defined by Facebook to solve this exact problem. Facebook have since clarified this license that applies to GraphQL, but Facebook have not at this time made any public comment on the standards course of GraphQL. So that, for us, that's a challenge. So it's a standards proposal going on. GraphQL is difficult simply because Facebook have not said what they're going to do with it. A lot of enterprises are using GraphQL, so Expect that that will resolve at some stage, but until then, GraphQL can't advance through the standards process, no matter how many of us use it. But I encourage you all to use it anyway because it's stable. It's ages since they updated it. It seems to do what we need to do, so it's pretty solid. So here's a simple example. So here we say, I'm going to fetch the base patient example, that's one out of the specification. And instead of just getting patient example, I'm going to get question mark, $GraphQL, query equals, and then a little fragment of GraphQL here. So the way GraphQL here works is that white space is irrelevant. So I will usually show you with a lovely little white space here on the diagram, the yellow box. When you actually make the query, you strip out the white space, just dump all the non-white space onto in as a parameter. Maybe you have to escape bits of it. Okay, so I'm going to just take that for granted most of the time. So we say here, given the JSON that you get for patient example, I want the name, and inside the name I want the text, and the given and the family, and so what you get back from the server is data, the data that is returned from running the query, name, which is a JSON array with given family, straight out of the example resource in the specification. And this page, there's a page in the specification called GraphQL, which includes all of these. These are just taken straight out of the standard. And you can actually launch these from this page in the specification straight against the test server. And the rest of the content that's in the patient resource is ignored, and you don't get it back. You only get back what you asked for. When you run into polymorphic fields where we value X, say an observation, you just nominate the JSON property that you want. It actually works directly against the JSON. So value quantity and a value in a unit, that's what you get back. That would be querying, assuming you were querying GraphQL on an observation. So before I get onto that, so it's actually pretty straightforward. You just use that, the curly braces to walk into the objects and iterate the arrays automatically, and you just pick out what you want out of the JSON for the resource. What you get back is not a resource. The MIME type of what you get back is application/JSON. It's a GraphQL JSON, which, as you can see, starts with either a data property or an error property. So you would get back error and a 200 OK. That's the way GraphQL works. Or you get back data and the content. So what you get back is not a resource. It makes no claim to be a resource, and it's not ever going to be a valid resource because you've plucked some properties out of what was the resource. Okay, now, when you're running into an array, you can actually I'm only interested in some properties of the array. And there's a number of things you can do when you run into a list. You can say, I'm going to write a FHIR path statement that selects which of the subnodes is to be included, or you can name a field that has to have a value, or you can do it by offset and count. So let's have a look at an example of that. Here I am, I'm iterating a name array, and I say, really, I just want to see the official name. I'm not interested in the other names. And so what I get back is just the official name, the given and the family, because I said I only want the official, the name, object in the array name, which has official as the value for use. And of course, that only works for simple elements. That's why we have the FHIR path, so you've got an escape clause to do really complicated things if you think you really want to do complicated things. The other thing this example shows is how you can actually rename an extension. This is just a standard part of GraphQL where you can rename a selection of a list. So in this case, you say, I want to have I'm going to list from the extension, I'm going to select all the extensions that have a URL of a named URL, and I'm going to rename them to myExt. which is just text that I chose at random here. And so instead of sending URL with an extension with the URL, you get back a named field element as if the extension was just an element. That's pretty nice. If you know which extensions you're looking for, you just get the server to rename them for you, and you can pretend that you just treat them as if they were that named element. That's not confined to extensions. This is the way GraphQL works. You can do that with name. You could say instead here, what I'm going to do is select the official name from the list of names, and I'm going to rename that to official. You could do that too. Here's an example of a FHIR path that allows you to say, I'm only interested in names if the name has a family name. So you get, for a full implementation, you get quite a lot of selectivity power on the client to say exactly what it is that you want returned. And then when you run into a reference, you name the reference that you want to follow, and you walk into it as if it was just more JSON, and the server just resolves that for you. There's a couple of parameters. One is to say it's optional. And if you say that it's optional, you just won't get anything back if there's no link. But if you say it's not optional, or if you don't say it is optional, the server will try to resolve the link, and if the link can't be resolved, then you'll get back an error saying I couldn't return what you asked for. And so typically in FHIR servers, classic enterprise information system EHRs, they'll never have broken links. Clinical data repositories, probably likely to eventually run into a broken link. Public test servers, almost certainly going to run into a broken link. And you can also specify which types you're interested in. You can say, I'm interested in a patient. If the subject of the observation is a device, I just don't want to know about it. Or if it's a subject is a device, then I want a different set of data to come back. More interestingly, you can also search on reverse references and actually ask the server to go off and find everything that references this resource and chase them down. So let's have a look at a couple of examples. So here I'm looking at an observation, and I've run into subject. I say for the subject, find the resource the subject references. Whatever you need to do as a server, you figure that out. And when on the resource that the reference references, if it's a patient, give me the birth date. So this ... on patient is part of the way GraphQL works. And then also give me the code, the LOINC code in this case. And so now I've got a LOINC code, probably a value and a birth date. So you can start prepping, very focused value sets. It's pretty cool. So I did a tutorial in Washington on Sunday about using R, which is a pretty mainline language for statisticians. So you can prep up exactly the set of columns you want to compare by getting the server to hunt this stuff down for you, and things that currently take people days to assemble value sets can turn into a few minutes to actually execute the prep and run the stats. So that makes it interesting because a server just has a list of observations. So instead of picking a particular observation, you can just say, hey, I'm going to query at the server root and say, list me the observations and do it by search parameter. So the first way is the simple way, which is where we launch, instead of at a particular resource, we say at the base, run this GraphQL, look up a patient that has this ID, and this form you require to nominate the patient. You must nominate the actual ID of the patient. This is synonymous with actually looking up the patient and just launching into the name and the ID here. But you run it at the server root. So it's just a syntactical variation of the same. So that's not very useful. But here, this is where we get pretty useful. I'm actually going to go to the server and say, server, for condition list, for all the conditions you have, if the clinical status is relapse, send them to me if the clinical status is relapse and it's on the example patient. And if you do, just send me the ID and the clinical status. Actually, that's probably you probably want a bit more data in practice, but this is what you get back. A list of conditions the IDs they have with a typo, there should be different IDs obviously, and clinical status is relapse. I don't know what happened with that copy-paste error or something. Of course, that's an entirely useless search in practice, but I'm sure you can imagine useful searches that you'd like to do. So you fill in the same search parameters as in the RESTful API. The server knows those search parameters, so you just call on those search parameters from the GraphQL engine. If you're a server writer, and I'll comment on that right now, if you're a server writer, you tuck your GraphQL engine just inside your RESTful query responder. And so it's going to call on all the same framework that you would be calling on if you were doing a search. And you treat it no differently. It just sits inside, basically makes proxy search requirements on behalf of the patient and builds a result set JSON. You whack that off to the patient. It's basically very light infrastructure on the side of the server if you implement it that way. You could also implement a GraphQL proxy in front of a server and call on all the services of the server. It won't be so quick, but it will work. But the problem with this condition list is really simple. It just gives you all the matching conditions. It's probably not so good if the matching list of conditions gets up past several thousand. Once you get past several thousand matching resources, it's starting to become an engineering challenge. So to deal with that, you can connect to a list of resources. You do the same query, but you actually start walking through the pages in a classical RESTful search fashion. It's just a wrapper for the full RESTful search with pages and scores and resources and matching and first and next and previous and last. You know how that works. And there's an example there, and there's a special GraphQL form which we defined for doing the next search, but running GraphQL on the next search. All right, so the GraphQL gives you full access to whatever the server gives you access to, but you are asking the server to do a whole lot of work you would otherwise do. If you're a client, it's pretty obvious what the advantages are. If you're a server, a few server manufacturers writers have said to me, isn't this like pretty expensive? And the answer is kind of, well, maybe. GraphQL is pretty simple to evaluate, to parse, and the engine's pretty simple. It's a very recursive engine with a few hundred lines of code. It's not rocket science. Yeah, your server's going to do a whole lot of work. But if your server doesn't do that, the client will just get you to do it anyway. And you'll do a whole lot of other work as well. So this kind of, maybe you could argue this encourages clients to get you to do a whole lot of work they probably just wouldn't bother. But that's a different kind of bad outcome. So my argument is you don't need to worry about auditing because you're doing it inside in front of the auditing trail mechanism. It should be saving work for your clients and saving work for your server. And it's relatively straightforward. So no, I'll come back to that. Now, that was all really good, but it's really interesting once you start flattening. So you know that in FHIR we have lots of containment and arrays and stuff, and for instance, patient name. We have a repeating name field, and full EHRs generally have multiple names, but there's a lot of patient care systems that only have the current name of the patient, just one. And you know when you query the system, you're only going to get one patient name back, but you get an array anyway. Or you might know that you'll get an observation code with a coding, and you'll never get a text and all you're going to get is a system and a code, and there's all these extra nodes there that are unable requirements that you're not dealing with. Wouldn't it be great if you could just get the server to collapse those? And then you might get a list of names back. Wouldn't it be great if you get the server to actually split the list up and you could just address the list as a series of named objects based on its properties? And you can do that with GraphQL. So here's an example. We ask for a patient and we get an identifier. We ask for the identifier and the system and the value of the identifier and the name. And we ask for the given and the family and the text. There's no text. So what we get back is the server just collapsed out identifier name because we said flatten them out, just return us the identifier and the properties of the identifier name. So they just fall out in what the server gives back to you. Hey, you probably noticed that there's some cardinality problems there. So actually that's what you get. You get arrays. Maybe that's not so useful, so this isn't always useful. It depends on the shape of your data. But you can do much more. I've only just, hang on. I thought I had more slides. I'll come back. I'll talk to it here then. Okay, so you can do this. There's a few other little they're called control words that also allow you to control. Maybe you just want the first of the list, whatever it is. You want to split up the list by a property. If you encounter, you want to flatten out the list as you slice it. There's a number of things you can do, which I'm not going to explain here, but are explained in the specification. And if you're feeding straight into a statistical analysis language like R, then these become really, really useful, because in R's got incredible libraries if you've got a data frame, but if your data frame is choppy and nested, then it's kind of really painful because you have to write all these iterator functions. GraphQL is really, really powerful there. But even if you're just writing a JavaScript-based client, you're sucking out some data, and you got to write these little JavaScript helper functions that you can just make them go away. All right. If you are interested in learning how GraphQL works, the test cases that I wrote for the Happy server and the FHIR and the Java and my test server are in this FHIR test suite. There's two sets of test cases. There's hundreds of test cases. One is deep tests against JSON resources for the GraphQL engine that you're going to write, and the other is a set of server tests that test the actual API representation. So you can test your server, and I assume that your server has installed the base R4 example set, and they're querying against the examples that come with R4, and you can get those correct. So if you're interested in implementing, those are really helpful. So GraphQL is a powerful tool for the client to reshape the data packet to suit their own purposes. It may be particularly relevant where data is passed to analysis tools. If you plow around the internet, one thing you'll notice is that there's some portions of the community that passionately dislike GraphQL. And in particular, my friends on the HTTP Standards Committee dislike GraphQL greatly. And really the reason is because, and I hinted at it before, GraphQL can't be cached. It's anti-cache properties. There's no way for a caching server, an HTTP cache, to actually grab what comes back and hold it and return it in place. The T tags and so forth they don't work. So there's no safe way to cache. What you're doing when you list your GraphQL at the server is saying it's going to go all the way through to the GraphQL engine, wherever that is, execute it there and come all the way back. And there's no way for a caching server to do anything to add value. If you're in the HTTP Standards Committee, you're obsessed with scalability. Those guys are obsessed with scalability, and so it really matters that you can cache content up. For instance, in HTTP2, you can write a query against the server for a page, the cache gets the page back, the cache grabs the page and injects all of the cached images for the page. It is cached locally, it's all transparent to you, it's magic, and you just get a fast browser and everyone likes that. And these guys worship speed. They don't like GraphQL at all. That doesn't mean it's a bad thing. It's just that when you're using GraphQL, you aren't going to get any help from any cache anywhere. You just have to understand the price of that, and either you like it or you don't use GraphQL. So currently, the servers that I know that support GraphQL, test.fire.org, and the Happy server, and the asymmetric server, and I don't know of any other servers that do. And I don't see anybody holding. Yes, there's a hand. You guys, AidBox does. Awesome, great. I'll add that to the slide in the future. I encourage other servers to take up GraphQL. I imagine it'll be a while before the EHR servers do, but in particular the general purpose servers, the ones that serve data analysis, secondary data usage, that's where it becomes really a technique that comes into its own. Because it just makes it so much easier for the client. And then we get back to the discussion that I had before. Does it cost the server time or save the server time? On the whole, I think it saves the server time. So for those of you who are in the GraphDefinition presentation, both GraphQL and GraphDefinition have the same basic notion. I've got a resource and I want to scan across all of its connections, either forwards or backwards, and retrieve information. But GraphQL and GraphDefinition have very different execution focus because the way we use them are different. GraphQL selects a subset of information from across the resources, and what is returned is not actually FHIR resources, it's just a JSON view on a set of FHIR resources. This GraphDefinition allows you to specify a set of rules about the relationship between those resources, and you can use it to retrieve the set of resources, but you'll get back a bundle with all of the resources in the bundle, and it has other uses as well. So although they're notionally in the same space about talking about relationships between resources, functionally they do very different things, and they'll be used by very different client libraries for different reasons. Of course, GraphDefinition has all sorts of other reasons, that other uses, the definitional uses that GraphQL does not. All right, we have plenty of time for questions. Do I have any questions? Yes.
On that bridge between the graph definition and the GraphQL, so GraphQL is an ad hoc query mechanism, which might not be a good idea for all purposes. I'm thinking privacy might not want to enable certain access ad hoc to certain elements. How do we see that? We want to put those things further together?
So it's some good points, good questions there. So the question is, do we understand that GraphQL is an ad hoc query mechanism? If so, does it have privacy implications, and how do you manage it? So GraphQL is envisaged as an ad hoc query mechanism. There's no, in the GraphQL specification, there's no way to name a stored GraphQL, as it were. It seems like something that we could be useful and we could define if people actually wanted, but nobody who's actually using GraphQL at this time has come forward and said that would be really useful, and all of the servers that have implemented it have just implemented a general purpose ad hoc engine. So this is kind of where we are at the moment. I think that when it comes to privacy and security and so forth, you can't let the engine that implements the GraphQL sit behind your security layer. It's got to sit in front of your security access control layer, because it is, on behalf of the client, accessing content that needs to be enforced. It has to be in front of that. Whether that means that you put it in front of your server as a whole, or whether you put it right in the front of your server, but it has to sit in front of your server security layer, because you can't let the client walk into stuff that they don't have the rights to access. So, I mean, it would only have privacy and security implications if you screwed up your implementation, basically. You've got to get that right. And for me, that's how I did it, and both in Happy and, or when James put it in Happy, it's tucked right in behind the RESTful API, the HTTP processing code. The first thing you do is you say, is this a GraphQL query? In which case I just run off into a sideline that's got access to all the things I was going to do anyway, so that, you know, it's very much at the front of your server. Any other questions? Yeah, Nikolai. Oh, yeah, thank you for reminding me. Mutations. GraphQL allows mutations. So you can submit through the GraphQL API mutations. It turns out that if you subset a set of resources and then say, I'm just going to change those data values that you sent me and send it back to you and say, here, figure out where this all came from and what it means to update all this, nobody knows how to do that. So GraphQL does provide a mutation API, but in the end, the mutation API collapses down to create, update, delete of the base resources, just like we already have as a RESTful API. So I looked at that and said, yeah, I don't care. It's it just doesn't do anything, right? So I didn't bother implementing it. I didn't bother specifying it. We have a RESTful API, use that. But it's the same functionality. So if someone came forward and said, hey, but I only want to have a GraphQL interface, I don't want to allow any of the other RESTful API, so is it okay if I do updates and creates and deletes by GraphQL mutations? Whatever, it's the same API. That's how I feel about that, and nobody who's implemented it has come forward and said, oh, we need to use mutations. So that's where the discussion is at the moment. I didn't think it was worthwhile, so I didn't spec it, and no one's argued with that. Of course, it would be lovely from a client's point of view if you could just, write your changes back into the subset that you got back and give it back to the server and say, sort that out. Never going to happen. The server has an information deficit against which to figure out what it is that you thought you were doing, since the server would have to match on the values, the original values, but you've changed them. It's never going to work. Any other? Yeah, Ryan.
So, Grahame, you were saying that it's problematic for a standards body, that it's not clear what Facebook is going to do with GraphQL. You can implement it as a server builder, but how do you envision to deal with GraphQL from the standards perspective? Will it be part of the FHIR spec, or is it just something that you choose to implement or not?
So the specification, it's already in the specification. There's a page, GraphQL, in the specification, which has all the examples and documentation, and explains that this is a Facebook specification with no standing. It's presently a trial use specification, trial use page. It will remain a trial use page until the status of the standard is resolved. It can advance through its maturity levels. I don't know how far we would let it go until Facebook get around to clarifying what they're going to do with GraphQL. If they turn around and say, well, that's it, we're going to withdraw GraphQL and not support it anymore, that's probably the best outcome, because then a community will arise and actually move it into some, maintained open public track. That'd be my preferred outcome. The alternative is that they just leave us all hanging, in which case the specification will be left hanging at some point, and then finally they might decide they're actually going to give it to a standards community, maybe IETF, or I don't know who else they would give, W3C, or I don't know who they'd give it to. W3C might refuse it if they listen to the HTTP standards voice. Who knows how that would play out, and then that would work for us as well. But it could be like Common Mark, right? Common Mark, we've pretty much committed to Common Mark normatively, but Common Mark is not a formal standard, but it's got enough community management and governance that we'd commit to it anyway. So it really, the ball's in Facebook's court. If you join the GraphQL support forums, you can see people, a number of people, including me, hammering away on them, going, you've got to sort this out if you want this to have any legs and any standing. I don't know if they do, though. They kind of seem to have had a flash in the brain and publicised it And then now they're left wondering what they're going to do about that. So I'm not sure. But if the worst came to the worst, we'll just stick with the old published version and say to hell with it. We're just sticking with that grammar. It works for us. And we'll ignore everything that goes on somewhere else if we have to. I mean, presumably we wouldn't want to do that, but it's an option. Okay, any other questions? Okay, so those servers listed here, ABOX as well. They support GraphQL. Go and have a bash and see if you can break the servers. Tell us if they're not consistent with each other. We're still filling out the tests on the server-side tests. Thank you very much.